It's kind of wild to think about what it actually takes to drill a hole miles and miles into the Earth's crust. It's so much more than just brute force. Really, it's this high stakes balancing act of physics, chemistry, and a ton of data, where pretty much everything comes down to one thing: speed. So today, we're going to drill down into the hidden science of how we get oil and gas, and why going faster is literally everything. All right, so here's how we're going to break it down. We'll kick things off with why speed is so critical in the first place. Then, we'll get into the physical and chemical roadblocks that are always trying to slow things down. And finally, we'll open up the modern driller's playbook to see how technology and data are completely changing the game. So, first things first. In a massive, multi-million-dollar operation like this, how do you even keep score? Well, it turns out that all that complexity, all that effort, it really just boils down to a single, all-important number. And that number is the rate of penetration, or ROP for short. The easiest way to think about it is like a speedometer for the drill bit. It is the master clock, the ultimate performance metric that the entire drilling operation lives and guides by. So why does this one number matter so much? Well, it's simple. Time is money, but on a colossal scale. An offshore rig can burn through hundreds of thousands of dollars a day. So if you can shave off even a single hour of drilling time, you could be talking about six-figure savings. That makes ROP way more than just a number on a screen. It's the absolute heart of the economic engine.
Okay, so if the goal is to drill faster, the obvious answer seems pretty simple, right? Just push harder and spin faster. Well, as it turns out, the rock down there has a say in the matter, and it's not nearly that simple.
At the most basic level, a driller really has two main levers they can pull. First, you've got weight on bit, or WOB. That's just the raw downward force you're applying. And second is rotations per minute, or RPM. That's how fast the bit is spinning. It's that careful dance between the push and the spin that actually breaks the rock. So the logic seems simple enough. Just crank up the weight, redline the RPMs, and just blast your way through the earth, right? But here's the thing. The rock gets a vote. And if you go too far, you hit this invisible wall, a point where pushing harder actually makes you drill slower. And this table here shows exactly what that wall looks like. At first, more force gets you more speed. That's what we call the linear phase. But if you push too hard, you hit what's called the founder point. The whole system just gets overloaded and your progress grinds to a halt. So what's actually happening? Well, a lot of the time, the bit starts to wobble violently off-center. It's a really destructive vibration called bit whirl. Suddenly, all your energy is just going into shaking and rattling instead of cutting new rock, which can completely destroy your equipment. But it's not just about the raw mechanics. Some of the biggest enemies of speed are totally invisible. They're these hydraulic and chemical forces. And funnily enough, they start with the very fluid that's supposed to be helping you drill. First up is this really sneaky problem called the chip hold-down effect. See, the drilling mud, which is under incredible pressure thousands of feet down, it acts like a hydraulic clamp. It literally pins the freshly cut rock chips right back down to the bottom of the hole. This forces the bit to waste precious energy just regrinding them into dust instead of cutting new virgin rock. But the drilling fluid can sabotage you in another way too, especially when you're drilling through these soft, super sticky clays that engineers have nicknamed gumbo shales. Yeah, this leads to a problem called bit balling. And honestly, the best way to picture it is trying to drill through mud with a bit that's covered in sticky chewing gum. That's pretty much what happens. That wet clay just packs onto the cutters, completely blinding them. Your ROP just plummets, and eventually you're just spinning in place, basically polishing the rock instead of cutting it. Of course, the ultimate opponent in this battle for speed is the ground itself. I mean, every single layer of rock is a different kind of enemy, and each one requires a completely different strategy to defeat it. So how do you fight back? By choosing the right weapon for this specific battle. You wouldn't use a sledgehammer to slice bread, right? Well, for hard, brittle rock like limestone, you need a roller cone bit that literally crushes and fractures its way through. But for softer stuff, you use what's called a PDC bit, which shears and scrapes the rock away, kind of like a super sharp plane on a piece of wood. And the level of specialization here is just incredible. Drillers obsess over every last detail. For soft rock, it's all about big cutters that can scoop out huge volumes of material. For hard rock, it's about using smaller, tougher cutters that can handle intense vibration. And for that sticky gumbo shale we were just talking about, they actually use bits with what are essentially nonstick coatings. It's pretty cool. So, with all of these variables in play, you've got weight, speed, hydraulics, chemistry, rock type. How on earth do drillers know if they're being efficient in real time? Well, they don't guess. They use data to get a live up to the second efficiency score. That score is called mechanical specific energy, or MSE. Now, look, the math behind it can get pretty complex, but what it means is actually very simple, and it's incredibly powerful. Just think of MSE as your drilling rig's fuel efficiency meter. A low score is exactly what you want. It means every drop of energy is being used perfectly to cut fresh rock. A high score, on the other hand, is a big red flag. It's a signal that you're just wasting energy, whether it's on useless vibration, friction, or regrinding those old rock chips. So how do engineers put all this knowledge together? All the physics, the chemistry, the data, how does that become a winning strategy? Well, they rely on a modern playbook, one that's filled with some seriously advanced tools and tactics. This is really where brains meet brawn. When friction becomes the main enemy in these super long horizontal wells, they use tools called agitators that literally vibrate the entire drill string to keep it sliding along. When the rock is nearly indestructible, they bring in percussion hammers. And now, they're even using machine learning, AI that analyzes data from other wells to predict the absolute perfect settings for the next foot of drilling. What this all adds up to is a fundamental shift in philosophy. The modern playbook isn't about brute force anymore. It's about finesse. It prioritizes cleaning the hole efficiently over just pushing harder. It uses data dashboards like MSE to diagnose problems instead of just guessing. And it's all about meticulously matching the right tool to the right rock for every single foot of the well. And this quote here, it really gets to the heart of it. The best drillers today see a low ROP not as some roadblock, but as a message from the earth, a puzzle that's just waiting to be solved. So the next time you think about where our energy comes from, just remember this invisible, high-stakes battle of wits that's happening miles beneath your feet, where every inch forward is a victory won not by brute force, but by science.